So that's the half. Take, yeah, keep it there.
Okay, pretty good on my end, it's a little off. Good enough?
Yeah, but that's how to verify.
So now we're gonna Davidoff
Pull it back on you.
Okay.
Okay, so to Davidoff it, we can,
And another way to verify, drop a look at are they the same? Yeah.
Now, do you do that to verify in a class from the top down?
she would.
Because that was what I was referring to as using some of the
Length.
the link
Yeah,
from
can do
the
that.
top to the bottom as opposed from the bottom.
Well, if I had all of the kids lined up, I would use the floor as
Right,
my
right,
marker.
right.
Yeah.
But
So-
you have
And then
strings.
have-
So help me
Right.
here, Melford. So if we're gonna do a Davidoff thing, this wouldn't be, this may be first grade, no longer kindergarten, so let's take that one.
Okay.
You know your Y thing? So we just put it out like this.
Oh.
And just in honor of Victor, who's not here, so the whole is K. For whatever reason, Victor likes K.
He does like K.
He does like K.
For the whole?
For the whole.
Oh, okay.
And then let's say this side is
A
and B.
B.
So then we have this little Y diagram, that's what you use, right?
Mhm.
So
Part
go ahead,
hole.
now you take it over from me.
Part hole.
So now go ahead and Davidoff it.
We would say A, quantity A, added to quantity A plus quantity B will give you quantity K.
Could we do it like this, length A
Yes,
plus
yeah, yeah.
length B
As long as we're
equals
focusing on length.
K.
Right.
Yeah.
We would,
So that
the
is-
general principle would
Oh,
say
before
quantity,
that,
but
though, I would think you would wanna say length A is equal to length B, because you
So
did
there we
have it.
go. So we do that.
That's why I
There
dropped
we
it
go.
to.
Yeah.
So we do
So
that.
you can see they're equal,
right?
yeah.
And then we also do length A plus B, we do this.
Right, then you put it back.
And we put it back, right?
Yep.
Now
And
Dora
this
and I
ver-
have done
this
this in
verifies.
first grade class,
Yeah.
I think fairly well.
Mm-hmm.
Yeah.
Right.
So that's,
Length A plus
this
length
is
B.
first grade.
Mm-hmm.
So what we're doing is before this, but this isn't a big step from what we just did in the other room.
Mm-hmm.
What you ladies think? God.
Body part of Jim begagelijk dus aan voldoen una stringak ang dani lukwag from here to here dus bigat matham duts
So if I represent, this is quantity K.
Yep.
That's the whole.
Hold down. We may or may not know, but this is quantity. Length A, this is length K, this is length B. And we know that A plus B equals K. When we drop them down,
Yeah.
we know that A is equal to B.
And that dropping down was the first thing you did, right?
Right, I'm not sure which.
Yeah.
Yeah,
The order there.
They also stretched it out to make sure that these they
and
come
we
up.
verified.
Yeah.
We're always
I thought I
verified. We
verified
verified multiple
two
ways.
ways
Right,
and then
verify.
dropped
Yeah.
it to make sure they were even.
So the dropping down.
So the initial verification that what essentially you've got is the A and B is the same as the K, and then dropping it down to have the A equals B.
That,
Evelyn, what you think?
Where is everyone?
So this length
Mm-hmm.
is what you guys are gonna be talking about.
Mm-hmm.
So they know already that this length would be the same as from your toes to your head.
Maybe, depends, they will.
And then if they already know that, then you can fold or find the middle. the center. And then if you want to see how long those things are, A and B, if they're the same length, then you can check. Because
Then
we're
it
always
becomes
checking.
this.
It does.
Because we're always checking
Becomes
to
what?
see if this side is equal to this side before we make.
If we lift the other string and put
That's
it up.
important.
Would you have, let's say me and you were trying this together. I'm trying to think maybe what you might do. So where it says K, would we do a picture like this? This equals K, not just
I
a string.
can picture K already in my head.
Go ahead.
But to make the whole, the K, I know that I have to use this to here to make my K.
But
So 2 of these would equal K.
would we use like the body before, with the string, in other words, to transition from this?
I would model the body first.
This first.
Yeah, the body of a child first.
Yeah, and that's
Measure
like what we
with
did in the
a
other room.
string.
That's like the pictures, the order of the pictures.
Find the center and then draw that.
So what we're thinking is what you just said would be the kindergarten and maybe
Kindergarten
first
would
grade.
get
And this would be the first grade.
Yeah.
Yeah, first grade down to.
After they've done what we did in the other room
Yeah.
and other such activities.
So,
I took pictures of your kindergarten.
Oh,
Evelyn, when we were in the other room, you mentioned, I can't see it, right behind the chair.
There she is.
Yeah, unfolded.
So you mentioned that you do this,
Isn't digital
do the half, and then you would get a piece of string
no words
for the whole. Would you get the string and find the center of the string, or you mentioned
Yeah.
you could get another
I
piece?
would make a young size string,
Mhm.
fold it in half, and measure from here to the
Ah.
tip of your finger.
To verify.
To see if it fits. Stretch it out and see if it fits your whole yakin.
It's so interesting. You guys are making a lesson that's more mathematical than we've written or the other consultants in less words. Very interesting.
But this is
Very
from
good.
our UP culture.
Yes, so no, this is, because you're embedding the verifying in multiple ways, and the kids could all do that.
And the teachers can do that because it's already in our books.
Do you ever, I mean, if you were, is there ever a reason where, with regard, if you wanted to know what this is and you're not sure and you can't, I mean, it's not always easy to get yourself a, would you hold a piece of string? Because you could physically get one from here
I
to here.
don't measure using diagonal. I always measure from here to there.
in
And yet-
Australia, they have those diagrams.
And in a sense, this is a function. Right?
Yeah.
So
Yeah.
you can see how those things nicely.
Help me, I always get stuck with function. It's a function because.
Because you're mapping one thing onto its double. Whatever link you have, and you map it onto its double. So if it's yours, it goes onto two of those. This in that sense becomes a variable. And the variable is the length of the arm.
Can't use variable.
I know.
You told
Not-
us.
Yeah.
I know, but
Who
it.
said Miriam?
but
Yeah,
this-
she said you can't use variable when I use variable.
Well,
Who said that?
No,
if,
never
if,
mind.
if
So-
A,
Anyway.
if A represents the length of a person's arm, then 2A represents basically, it's not a perfect one, but it would be, you know, in the modeling world, if you set up, measured these things out and graphed them, it's likely y equals 2 is the best regression equation that you would get, right? Or it might be 1.995 or 2.0021 or something. It is basically a function, and archaeologists or whomever go out and dig up body parts.
Well, it's
have
a
lot of those.
two-time function.
Yeah,
Right.
yeah.
That's a-
It's a what?
A two times
Yeah,
function.
The doubling function.
Doubling function.
I made the mistake of saying variable with Miriam, and she said. And then I compounded the problem by saying one's an independent and the other one's dependent.
Oh, well, you stuck yourself in deep.
You went really down that path, huh?
For this particular one, A represents my arm length, and so it is not a variable, it's a quantity, but if we, so I'm just being cautious,
In Measure Upper, we use the capital letters for quantities, and then the small letters became our variables when we got to that point.
But if it was anybody's arm length, it would magically be a variable.
then we would use the small letter to represent, let A be